Okay, this is lesson 9, part 2. Build your skills number 10. And we will also be doing build your skills number 11. And number 12. So Get Fit Fitness Center charges $75 to join, then $25 per month to be a member. So that $75 is again what we would call the flat rate. Same idea. And A, draw a graph that shows the cost of being a member for 1, 5, and 10 months. So what I did here was I set up a table and I got 1, 5, and 10 months, and X is going to be our independent variable. So we need to figure out what the cost would be for 1 month. So $25 for 1 month plus the 75 flat rate. So it's going to cost you $100. For 5 months, you're going to have to go 25 times 5 months and add on the flat rate. So 200. And then it'd be 25 times 10 months plus that $75 flat rate fee, and you get 325. Okay. And now we can plot this. So 1 and 100, 5 and 200, 10 and 325. So 1 is right here. So these go in increments of 2. So this would be 1, 1 and 100. 5 and 200. 10 and 325. So right there. And we use your ruler. So on your assignments, make sure you're using a ruler. Or again, debit card, anything with flat edge, really. And link those two together, or those three. Okay. And we have it plotted. B, write an equation that shows the relationship between the number of months of membership and the total cost. Okay. So if it's linear, which it is, you're probably wondering, so like, where do I even start? Well, if the graph is a straight line, it's going to follow this equation, right? So y, m is the slope. Okay. For us, let's try and figure out the slope here without even doing the rise over run. You can do that, but remember I said the slope is a rate. So anytime you see per something, okay, right here, that is your slope, $25 per month. Anytime you see that, that's your slope. So 25 times X amount of months plus, now what would our y-intercept be? Well, it's not on our graph, but we can kind of work backwards here. And if I were just to draw it on, you might clue in. There's where the y-intercept would be. That looks like 75. Well, that's this piece right here. And I don't know if you noticed, but really we went 25 times 1 there. This is the equation. 25 times X amount of months plus 75, because the y-intercept is where you start. So when you go to a gym, you have to start at $75 no matter how many months. That's another way to think about it. Okay, so we'll add on 75, and there's our equation. So a lot of the time, you don't realize that you're calculating using this equation in your head. You might be doing it in reverse order. You might be going 75 plus 25 times however many months, but it doesn't matter. If you rearrange it all, it'll fall into place like this. So C, how much would it cost to be a member for 9 months? Now, again, in your head, you might go 75 plus 25 times 9 and add it all up, right? Well, if you just reverse the order, right, you could just go 25 times 9 months and then add on that flat fee. So you're probably doing that in your head already. Comes out to $300. Okay. All right. Number 11. The temperature on a winter's evening decreases by approximately 1.5 degrees every hour from 4 p.m. as the evening progresses. So temperature goes down as it gets darker outside. I just want to underline this part, 1.5 degrees Celsius every hour. Another way we could say that is per hour. Right away, that tells you the slope. Okay, so I got a graph here for you. Here's the time: 4 p.m., 5 p.m., 6, 7, 8, 9, 10, 11. And then I got temp, and I got 3 degrees, and it goes down all the way to negative 12. This line here is just the x-axis. Okay. Now, A, if the temperature was 3 degrees at 4 p.m., so 4 p.m. was my first spot, draw a graph to represent the decline in temperature until 10. Okay. So what we kind of need to do here is make a table, or we could just think about it logically. So let's try and do it without a table this time. If I were to go 1 more hour into the evening, it should go down from 3 degrees down to 1.5, because it's gone down 1.5 degrees at 5 p.m. Right? So I went down 1.5. Okay. And then if it's 1.5 degrees out, it's going to go down another 1.5. So if I go over an hour and go down 1.5, I should be at 0 degrees. And what I'm trying to do here is show you that we're doing the rise over run to find the slope, right? We're going down 1.5 degrees every hour. Okay. So go over an hour and go down 1.5. Over an hour, down 1.5. Over an hour, down 1.5. Over an hour, there's a half, one more to there, negative 6 degrees out. Go over an hour, down 1 and then a half. Oh, we only had to go to 10. All right, so I'll take that one out. And there you go. That shows the steady decline of the temperature if it goes down 1.5 every hour. Oops, that's a bad line. Try that again. Okay. There you go. So when you do your rise over run, this would be down 1.5, forward an hour. So what is the slope of the graph and what does it represent? Well, slope, which is m, equals. Now I could do the whole line if I wanted to, right? I could go down from 3 all the way to 6, right? So that'd be down 9 over 6 hours. I could choose any part of this, or I could just answer it down 1.5 degrees per hour. So down 9 over 6 hours. You divide those two, get negative 1.5 degrees Celsius. Now, in other videos, I also showed you that you could just go do the rise over run, and then because it's a downward slope, you just add on the negative at the end. So if this part confused you here, you can just add it there. So remember, any graph that goes up from left to right is positive slope. Anything that goes down is negative. Or again, you could just, it went down this much per hour, right? I'd be okay with you even putting per hour. That's fine. So what would the temperature be at 10 p.m.? Well, we just use our graph. We don't have to crunch any numbers. We're going to go over -6. Do you think this trend would continue all night? Why or why not? Well, for this one, I put no. And there's tons of reasons. I mean, overnight, it can only get so cold, right? There could be a lot of other factors too. There could be the wind chill. There could be any kind of snow, rain. A lot of other things can affect the temp. So I just put no. It can only get so cold overnight. Also, the sun will eventually start to come up. Okay. So eventually, like there's going to be a point where, the sun isn't visible, but you can still see that it's about to come up, right? So that's going to add to some heat. So there's a lot of factors. Okay. But the best one is just no, it can only get so cold overnight. Okay. So you can add in anything else you want there. We'll just leave it at that. Okay. 12. Ellie is heating, ventilation, and air conditioning. So HVAC. So H for heating, V for ventilation, AC for air conditioning, repair person. And when she makes house calls, she charges a flat fee of $50 to show up. And then on top of that, 3 hour or $30 per hour. So right there per, that's your slope. $30. Okay. And the flat fee, you guys should know, is your y-intercept. So an equation would be y equals $30 times X amount of hours plus the 50 that she charges initially. And if you want to replace the y and the x, you can have cost 30 times hours plus the $50 flat fee. Okay. B, how many hours would Ellie have to work to charge her customer $230? So okay, so cost, charge, same thing. 230, 30 times your hours. You could put an X there if you want. plus the 50. Okay, if we want to figure out how many hours, we should subtract the 50. It's plus 50, so you got to subtract. So take off that. This is essentially what we're doing. We're taking off the $50 flat rate fee to figure out how many hours she worked. That's really all we're doing here. So this turns into 180. Then you have 30 times hours. Okay. So divide by 30. How many hours? 180 divided by 30 is 6. And that is the end of lesson 9, part 2.